What is the mover of matter? Energy. Energy is the mover of matter. It's what makes stuff happen. Energy is all over the place. And, well, nothing would happen without it. It's kind of important. We wouldn't have sports we enjoy playing. We wouldn't have the technology we enjoy. We wouldn't have lights. We wouldn't have cars. None of this stuff would happen. None of it would work if there was no energy. We kind of have to have it. It's a bit important. Now, energy is defined in science as the ability to do work or cause change. And by work, we just mean taking something from one place to another place. That's it. So work is just movement of something from one place to another. And all of this change, if there is change happening, there is energy. And we know that things are changing all the time. Can't help it. It just happens. Energy is measured in a unit called joules. So whenever we have some magnitude and amount of energy, we write a big uppercase J afterwards to signify that we're talking about joules, and note that spelling. Now, let's talk about us. What exactly do we need energy for on a day-to-day basis going through life? What might we need it for? Let's think about this. So take a moment and think about through your day what things you use energy for. Go ahead and pause the video. Jot down some ideas in your notes. So some things you might have written in the morning: eating breakfast takes some energy, moving that spoon, right? Or moving that ham and cheese and egg croissant in your mouth, right? Takes some energy. Cup of drink up to your mouth in the morning. Getting on the bus, going to school, takes energy, going from one place to another. Things are changing. Even sitting in the desk at school takes energy. You got to get there. You got to sit there. You got to move the pencil. All of these things take energy. Lunchtime, same thing. You're eating. You got to use some energy to do that. Going to that last part of the day, maybe you have your PE class. You definitely need energy there. You got to keep moving around. You've got to get from class to class. It takes energy. Your evening, maybe you're at practice, right? Running around there, or you have an activity that you're doing. All those things, all the stuff, that Chromebook you're using, those electrons that are traveling around as far as electricity goes, all those require energy. The lights that are lighting up the classrooms that you're in, or at home when you're finally at home in the evening and ready to go to bed, brushing your teeth, that takes energy too. All these things take energy. Now we can classify energy in two ways, right? We got the kinetic energy, which is the energy of motion, and we have potential energy, which is stored energy. If something is moving, it has kinetic energy, and the faster it moves, the more energy it has. Potential energy, we're storing it. It can be used later. And these types of energy can be transferred from one kind to another. An example of potential energy is potential elastic energy. Elastic potential energy is when there is a compression or a stretching, like in this bow. You can also think of a rubber band or a spring. These also have elastic potential energy. And if you notice in the bow, when you let go, that potential energy is changed to kinetic energy as that arrow goes flying. Another form of potential energy is gravitational potential energy. This is energy that's stored based on its height from the ground. And the greater the height and the greater the mass, the more potential energy that it will have. Now, if we drop something, that gravitational energy will change from gravitational potential energy to kinetic energy as it goes faster and faster as it falls. This is a transfer of energy. Here's an example of a ball rolling down a hill. At the top, we have the most gravitational potential energy, as you can see in the graph, which you should be writing down in your notes. It changes as it rolls down into kinetic energy, and then at the bottom, it has the most kinetic energy because it's going the fastest. So it changes from potential to kinetic energy. Draw the bar graphs for each of these locations on this roller coaster. We have the most potential energy, of course, at the top, and then we get to the fastest at the bottom. We have the most kinetic energy. So take a moment and draw those graphs in, just like we had in the previous one. Now, in summary, kinetic energy is the energy of motion, and the faster something goes and the more mass it has, the more kinetic energy it has. Gravitational potential energy is a type of stored energy, and the greater the height from the ground and the more mass it has, the more gravitational potential energy it has. So there you have it, basics of energy.